Hi, welcome to City Projects. Now we discuss about project of here it is building minimal classification rules for the breast cancer diagnosis. It's a kind of a medical related project, and mainly we compare the classification algorithms and find the best classification algorithm for best for the breast cancer diagnosis, data classification and prediction. Let's have a look to the project stuff. I made a sample, some simple PPT. Title of the project, and comes to the abstract, we explain the the classification algorithms are have a major role in medical related data, and best classification algorithms can get accurate results from the historical data. That means previous patients data. This is machine learning, getting the results automatically by observing and learn from the history data. Okay, so mainly this paper finds the prediction and best classification algorithm by comparing the results among the decision tree and random tree. So we prove that based on our experimental results, breast cancer data, our experimental results on the breast cancer data set, J48 decision trees are classified is found the best among the classifiers. And comes to the existing system, by simple observation, mainly current systems that may be hospitals or something, uses the limited and simple functionalities like prediction of diabetes by simple statistical predictions and clustering the data for a few units, like I mentioned here, clustering the patient's ages by any disease. And this is a simple machine learning usage and existing, mainly the existing system, not completely using the machine learning in breast cancer diagnosis. That is a final point, major point of the existing system. And we using the proposed, I mean, that means we overcome the proposed system that we apply the machine learning concept in breast cancer diagnosis. And comes to the disadvantages, and no analysis of the previous data, and we are not in the existing system, they are not using the historical data. I already told you the previous patients data. And next, simple statistical solutions like a prediction of predictions and a clustering of a you know some simple requirements like finding the diabetes is like that, like finding the diabetes is not more than required, like age, weight, that's it, no? So simple, that is the simple statistical solutions. And majorly those are the previous what are the doctors, with their experience, they made the solutions, not analysis and classifying the things in the proposed system. Yeah, first one classification definition, and second one it's a rule based rule based definition. This is very important, and we make the decisions in rule based classification by using the if else kind of a things. For example, if positive score is equals to 20% and negative score is equals to 10%, then what is the result? Obviously it's a positive, it's 20 greater than the 10. And we use the rule based classification in our project, and we predict the cancer diagnosis for the user parameters. You can see in the user models. Yeah, finally we make a conclusion in proposed system that we got the J48 decision tree is the best rule classification algorithm. And comes to the algorithm, I'm comes to the algorithm. Yeah, this is the algorithm. This is mainly it's a three steps. First one, calculation of the entropy, and it's a I simplified the this formula. P means positive score and N means negative score, log base 2, and some mathematical formula of a decision tree. And the next, split entropy, say, a calculation of the split entropy of a variable. I mean, the attribute X is an attribute that may be positive or that may be negative. And next, Final step, no, not final step. Step 3 is a gain. We calculate the gain. For whatever the first score we got minus the second score, and that score we compare with the positive and the negative. This is called rule-based classification. As a result, is positive if the positive is greater than the negative, or else result is negative. Let's back to the PPT. Yeah, advantages of the proposed system. We can predict the results using the rule-based classification we discussed, and dynamic nation prediction. Like we can give the input data and number of data. We can update the data also, and come to the system configuration. Two system configuration: hardware and software. And the hardware, it's any updated processor. RAM is minimum. We require 1 GB. Hard disk minimum 100 GB. And comes to the software requirements. Operating system, we use Windows family, any kind of a Windows XP to 10, and technology we use the Java J2EE. Version maybe we can use the 1.7 or 1.8. Web technologies, HTML blah blah, and web server is Tomcat 7 or 8. Database is MySQL I used. And let me clarify, and we very soon we develop this application Python too. Okay, and the data coding language will be Python, and database will be the same as same MySQL. Next, let's see the data set. What I use comes to the data set. I research in breast cancer. Like very hard, and it's a 3 level of cancer, and almost it's curable cancer only. And I learned a lot of details like what are all the parameters taken to make the decision by the doctors, etc. And let's see the data set. Yeah, here it is. I found in internet, and I cut some of the data set for the testing purpose. This is a training data set, and I cut the few data set for the training purpose. So testing purpose, and this is a training data set. And we have a few attributes. First one is marital status. M is a married, and M is not married. And second attribute is a lymph node metastasis, and 1 is positive, 0 is negative. And third one is estrogen receptor, and fourth one is progesterone receptor, and last one is lymphovascular permeation, and it's a cancer positive. What is the result of the existing patient, positive or negative? And one, I already told you, 1 means positive, 0 means negative. If this thing got a positive, and this thing got a positive, and this thing got a negative, and this thing got a negative, existing patient have a positive, means has have a cancer. That is a data set. It's all about the 300 records, and I cut some of records for the testing purpose. Yeah, 10 records, 15 records, 20 records, 25 records, 30 records. Yeah, this is 30 records. Yeah, let's see the implementation. Yeah, this is a home page, and this is the IEEE link where I refer this paper. It's a 2018 paper published one. Next, we have main modules: admin and user. Admin, I'm logging as an admin. It's a user ID password is admin statical one. Doesn't need any registration, and admin has a few operations: data set upload, view, data set classification, and evaluation. And comes to the data set upload, we can upload the data set what we have, so that will be stored into the database. So I'm going to upload where this dataset breast cancer dataset is 300 records. Yeah, it won't take more than 1 minute. Yeah, dataset uploaded. Yeah, if you want, we can see the dataset. That is a view dataset option. Yeah, this is dataset we uploaded. Every time it will refresh in the datasets. For example, if if you updated to the 400 records and uploaded, the previous 300 records will be deleted and added the 400 records freshly. Yes. Next, we have a classification and evaluation. So before going to this application, once I want to show you the user module. So I'm going to user. So for the user, we required user ID password. So for that, we need to sign up. Yeah, user data added successfully. I got a positive response. Next user, email ID and password. Yeah, I have a one option, prediction. See, in the user side, I'm predicting the cancer, the breast cancer by using the decision tree. Simple directly decision tree by using the single decision tree algorithm of the predicting. This is a major. I mean, here I can explain more about the algorithm. See, if the any patient came to hospital and she's a married and she got a lymphoma, this attribute is a positive and this is positive and negative, this is negative, and this may be a chance to result is a negative. Why? Because this is a frequency table, the positive one and negative one. If you combine these, you will get the 300 score, and the entropy of a class is a score we got, and the step one of my algorithm entropy, next split entropy, next gain. Yeah, next split entropy, splitting entropy of a positive, split entropy of a negative, and we got the score and gain entropy minus this one, entropy minus split negative, and whatever whichever I mean the is a rule based about which attribute is a higher, that is a result. So negative is a higher, so negative score is a higher, so that's why I got the negative results. Prediction, positive, negative, negative, and it's a married. There may be chance to positive. Yes, we're very lucky. We saw the both the things results are positive and negative. And come back to the admin now. Admin and admin. Now see the main functionality of this paper is a classification. We have to find the best classification algorithm. So now I'm uploading the training data set. For example, I'm uploading the 25 records. Yeah. So this is it's a testing data set. Upload testing data set. Yeah. See the this is the original output. Actually, the existing patient, whatever the existing patient, she has a there is no cancer, but I predicted negative. That means it's a correct. I mean, whatever the existing patient with these records, she has a no cancer. I also predicted the no cancer, so that means correct. There may be chance to wrong. See here for these parameters. male 1001. Actually, she got a positive cancer, and I predicted negative. Means wrong. Some cases wrong. Why? Because in no algorithm give the 100% results. So wrong. We get a some wrong and many of the correct result, correct, predictions only. And next, this is the classification by using the decision tree algorithm, which we already saw step by step in the user side. But user side we have it taken only single row by manually, and we predict the thing. But here we take the bunch of testing data, and we predict all these things. And also next we are going with the random decision tree. This is a random decision tree. I mean random tree. Many of the predictor is wrong only. So only few correct. And we can see the instant graph results. So almost 50 in 50 records we got a 40 plus 40 plus are correct, and out of 50 some few is correct. This is success code and total count. If I am doing classification with another data set, yeah, I'm taking 50. Yeah, by using decision tree and by using the random decision tree. Yeah, 15. We got a 14, and here out of 15 we got only corrected one, only 2 out of 15, only 2 is correct by using the random tree. Here in the by using the decision tree, only 14. Classification. Next 13. Here I got more wrong. Decision tree. Out of 30, 25 got correct. Here out of 30, only 5 got correct. Now see total evaluation, we comparing the both the algorithms results. Yeah, this is a dynamical graph only. So we the trained the testing data set is 10, 15, 20, 30, 50, and the see here decision tree. This red one is a decision tree, and the random tree is a blue color one. So we got a best score to random tree compared with the decision tree. So apart from, I mean, as we conclude the proposed system, we got a best score, best results in it by using decision tree. Okay, that's it. You can call for a small demo of the project or any deep explanation of the project, and we got this rating. And thank you for watching, and please do subscribe. Thank you.